All right, hey there, ladies and gentlemen. Today we're going to be looking at exponential functions. So the function that you're normally used to, yellow's not a good color, the function you're used to seeing, or the couple that you're used to seeing, would be y equals mx plus b, and then you also have y equals ax squared plus bx plus c. Well, today we're going to be looking at y equals a times b to the x. So the difference here is that your variable is going to be at an exponent. So first of all, we need to see the difference between the two. You know, normally when we have a table, we look at finding the slope. So what we're going to do is use the y value to see what it is changing by. So each time here, it looks like I'm subtracting 4. Well, I'll look at the other table here. It's kind of hard to see until you start getting further down, but here we're multiplying each time by 2. So this is what we call an exponential function. Well, this one is just a linear function. So if we were to graph a linear function, so if this is our coordinate plane, a linear function would just be a straight line that looks like this. While an exponential function, it's a lot different. It's going to be a curved line that looks something like this. So we'll look more at these graphs. It's almost like an L shape with a little bit of a curve there. So when we look at the equation for an exponential function, the a represents the initial value, or like, well, I guess it is too early for me to be writing value, or like the starting point. While b is what we call the growth or decay factor. So when we have growth, a is going to be greater than 0. Actually, let me rephrase that. A is going to be greater than 1. I'm sorry. While the decay would be between 0 and 1. So in this case, we're looking at like a fraction or a decimal. So as we move to the next piece, we're going to determine if these functions are exponential or linear. So I'm going to use these y values to see. Now, first of all, I always look at the last value and I'm like, okay, is it giant or is it kind of eh? So in this case, it's giant. So more than likely, we are going to be multiplying. And it looks like in this case, we're multiplying times 4. So this would be exponential. While here, it looks like we're adding 3 each time. So this is definitely going to be a linear situation. When we have an equation, we want to look at where the variable is. And in here, my variable is as an exponent. So this makes it exponential. While here, we're multiplying by the variable, so we're back to a linear situation. So here are what the graphs look like. So this first example, I would sketch it something like this. If you notice here, the base is more than 1, so a is greater than 1. This is what we would call growth. So I would sketch to show that it is growth. So we're going from I guess something like this would be growth. So going up from left to right. Well, here, this would be decay. And we know it's decay because these values are less than 1 but greater than 0. So when we sketch decay, decay goes down like this, from left to right. So when we look at these graphs, this first one is going up from left to right, so this would be growth. Well, this one is going down from left to right, so it would be decay. Oh, whoa. Now the next piece is asymptote. I want you to write that word down. We need to be familiar with it. The asymptote is a value that So in the asymptote, this is where the y values are approaching 0 but never actually reach it. So just to kind of zoom in on what you see here, there's the x and y axis. So here's our x-axis, our y-axis. As you look closely here, the values go, and they start getting super, super close but never actually touch the x-axis. So they don't touch the x-axis. Just hit a bunch of. So when we look at this graph, we're going to identify the y-intercept and the horizontal asymptote. So what's going to happen is it looks like it's going to be touching this value here, but it's not actually. And then, of course, our y-intercept is here. So let's do that first. That's where x is 0. And it looks like we have 1, 2, 3, 4. So 0, 4 would be that y-intercept. And the horizontal asymptote looks like that would be 1, 2, 3. It actually is approaching this. So it would be where y equals 3. Now, as far as domain and range, these values actually continue in both directions for our domain. So this would be an all real numbers situation. But the range is a little different. We're going to use that horizontal asymptote. So it's going to be the values from this line here, and up, but not including that value. So when we write our range, it's all the y values that are greater than 3. And in this case, this would be a growth because it is increasing from left to right. All right, let's look at another one. Again, we're going to identify all of these things. So first of all, this graph is actually approaching the x-axis, so our horizontal asymptote is either going to be the x-axis or where y is equal to 0. As far as the y-intercept is concerned, they're not numbered, so we'll just go by 1. So this would be 0, 1, 0, 1. Our domain, all real numbers because it does continue in both directions, left and right. Our range is going to be y is greater than 0, and this would be a decay. And remember, decay has that a value that is between 0 and 1.